Hello viewers, we are going to start a new video series, and this video series is about manipulating the time series data. Time series data you will find everywhere. Anything with a timestamp is a time series. For example, product sale, website traffic, stock prices, weather data, these are all examples of time series data. It is used in many industries, including finance, manufacturing, retail, pharmaceuticals, to name a few. Time series data is important because it allows us to understand the past. It allows us to understand the trend of the past data. And based on the trend of the past data, we can also predict the future. So let's begin with defining the time series. A time series is a set of observed values ordered in time, or we can say repeated measurements of something, usually with the same fixed interval of time, and that interval of time can be hour, can be week, can be month, even can be a second as well. So in a time series, observations are recorded at evenly spaced intervals. For example, product sales, typically they are recorded daily, whereas share prices, they are recorded every minute. Economic parameters of the country, they are recorded quarterly or yearly. Some parameters are recorded yearly. For example, when the company closes its books of accounts at the end of the financial year, the company turnover is recorded yearly. Some measurements, for example, IoT sensor measurement, temperature sensor, streams the data of the equipment in every milliseconds. So these are some of the applications of time series data, and there are endless such applications and so ubiquitous. R also has few data sets inbuilt which are used to analyze the time series data. For example, this data from the mass library. This data is about European stock market movement. It contains daily closing price of a major European stock indices. You can see the daily stock market trend over the 6 years. Have a look at this data. Again, a time series data. This data is about air passengers. This data is about monthly count of international air passengers. Because time series data is so common, in R there are two special time series classes. They are called as a date class and POSIXct class. These classes have special functions that work effortlessly with time series data. They ensure that each observation, time and value are tied together so that they are not easily separated during analysis. Now, one of the important characteristics of time series data is that it always comes in pairs. So you have the observations and you have the time series timestamp of that observation. So whenever you are analyzing a time series data, it has to be done in pairs. So this may not be possible with other data structures such as vectors and data frames. So R has created a separate dedicated classes of time series data so that it becomes very simple to analyze any time series. We will also see some of the popular data time series manipulation packages such as zoo package and lubridate package. We are going to see some of the functions from these packages as well. Fine, so we will going to start with lubridate package. Lubridate is a R package that makes it easier to work with times and dates. This package is recently included as a part of tidyverse package family. So if you are using the older version of tidyverse, then you will have to separately install the lubridate package. So you will have to check this before proceeding. So let's import the time series data. This data is a CSV file which contains the daily closing stock price of Infosys Limited. Infosys Limited is an IT MNC from India, and this data is sourced from National Stock Exchange portal. Now, whenever you are dealing with the time series data, you need to be extremely cautious about the object class of time component. Now, in this data set, the time component is this date, but you will find out that this date is not a time series object. However, this date is a character object. So if you want to check the class of this date variable, then you will find out that it's a character class. So before manipulating a time series data, this will be the first step that you will do, or even before plotting the time series chart or even building any time series model. This is the first step that you will have to carry out, is you must convert the time component of the data into a date class so that R will recognize it as a time series object. Now here, the time component, that this date variable is not a time series. This date variable is not a date time object, it's a character object. So our first task here is to convert this from character into a date class so that R will understand it as a time data. Okay, so there are various packages, so there are various functions that are parsing functions, we call it as, that are available in lubridate package to convert the dates from character class into a date class. Okay, so we are going to see some of those functions in this video. Now, in order to use those functions, you will have to simply identify the order in which the year, month and day appears in your dates. So in our data set, this is typically the date looks like, and if you find the order of this date, the order goes something like this. It's a day, so this is a day, 16 is a day, February is a month, and 2024 is a year. So the order is DMY, and that becomes your parsing function from the lubridate package. So DMY is your parsing function, and we are going to use this parsing function on the date variable now. Okay, with the help of a muted function from the dplyr package, I converted the date from a character class into a date class with the help of DMY function, parsing function. And if we want to check now the class of this converted date variable, you will find out it's now converted into a date class. And you can also see that all the dates are converted into a standard structure. This standard structure is as per the ISO 8601 format. ISO 8601 format is a standard format for the time data representation. So the format says that the time elements are ordered from the largest to the smallest. So each date you will find out starts with the year, because that's the largest part of time. That's the largest part of the date, then the month, and then the day. So let's try out this DMY function into another data set. This time we will going to import the IoT temperature sensor data, and this temperature sensor data is streaming every hour. So this is the hourly data of the room temperature. Again, the first step we're going to do here is to check the class of the date time. Now here the time object is this date time variable, and you can see the class of this date time variable is character. So R will not recognize this date time variable as a time object. So let's use a parsing function from the lubridate package again. And if I want to find out the order of this date time, the order goes something like year, then month, and then day. But here the date is also followed by the time, The time order goes something like hour, then minute, and then second. So YMD is our parsing function because that's the date, that's the order of the date. But here we will have to also use HMS. H stands for hour, M stands for minute, and H stands for seconds. So YMD underscore HMS will be our parsing function. So let's use this parsing function on date time variable. And if I now check the class of date time, it is converted from character class to POSIXct class. Now this POSIXct class is different than a date class that we have seen earlier. So POSIXct class has the date component, the time component, and also this UTC is a time zone. UTC stands for Coordinated Universal Time. It's a standard used to set all time zones around the world. So POSIXct has three components to it. It has a date, it has a time, and it also has a time zone. It can also set a time zone with the help of POSIXct object, with the help of POSIXct class. Lubridate pass function handles variety of separators. So far we have used this dash separator to separate out the year from the month, from the date. Now we will see some of the other separators. Have a look at this date, the date1 object here. it doesn't has any separators, so it only has the numbers. And if I execute this, if I use YMD parsing function on date1 object, then it gives me it converts it into a date class as well. So why YMD? Because 2024 is the year, then 03 is the month, and 22 is the day. So you will have to figure out, depending upon the numbers that you get, you will have to figure out the order of the date here. So and accordingly the combination of YMD you will have to use. So this is without separator. Now this date2, it comes with a / separator. So, and the order is the day, then the month, and then the year. So that's why we have used DMY as a parsing function here. And if I use this, then it also gets converted into a date class with a standard ISO 8601 format. Now in this case also, date3, we don't have any separator. But what we have here is, in addition to the date, we have also a time component to it. So the date order is year, then month, and then day, so YMD. And the time ordering is the hour, and then the minutes. So YMD underscore HM is the parsing function that we used. And it has given us the POSIXct class because we have the time component to it. Lovely. So let's summarize. A time series is a set of offset values ordered in time. In R, there are spatial time series objects. These objects are date time objects. They are designed to work best with many time series statistical models and visualization libraries such as ggplot2. Before manipulating the time series data, we must ensure that the time component of the data set is converted into a date time object with R, which R understands. So remember, when we imported these two data sets, the time component of the data had a character class. So we had to convert it from character class to a date class, or the POSIXct class. So that's the first step. That's very important step that one must follow in analyzing any time series data. In R, there are two classes that we saw, the date class and POSIXct class, which are exclusively designed to handle date time objects. And we used various combination of parsing function, the DMY function from the lubridate package, to parse the date and times. So we have come to the end of the video. Thanks for watching it till end. If you have any suggestions, comments, please write them in comment section. Your inputs are very valuable and will massively help me in improving this content further. If you want to get notified on all my upcoming videos, please also do subscribe to this channel. Thanks for watching. I will see you soon.